All right, hey, good evening. Thanks for tuning in. So this definitely was something that I think for some of us went well, and for other of us, I think could have gone better. And so I'm making this video, and I hope that you take this as an opportunity to kind of maybe figure out where you are doing well and where you still need to work. Unfortunately, there's just not any time to continue to go through this. I need to move on. So again, this is your opportunity to kind of try to figure things out. And if you're still lost, maybe that's a sign that you need to really reach out and get on top of this. All right, so I'm just going to go through each of these problems. I'm going to kind of explain the idea behind it, and then show you maybe places where we were successful and places where we could have, maybe improved. Okay, so this quiz was about factoring. Okay, and so the idea behind the bulk of it was factoring completely. Okay, and as we discussed, right, that means using a variety of tools that we now have in our tool belt to break down or factor these polynomials until they cannot be broken down anymore. Okay, and I'll show you in various instances what does that look like. Okay, so to remember some of the strategies we've learned, and this is actually goes back to August, right, is factoring out a GCF, greatest common factor. We've talked about difference of squares last year and recapped this year, right? We talked about varying ways to factor quadratics. This unit we focused on a couple of new strategies, those being factoring by grouping and sum and difference of cubes, okay, both of which, the latter two, which are available to you without really any need to memorize, okay, and so those are in some ways are going to manifest themselves in this assessment, and we're going to see how that happened. Okay, so let's dive in with a little look at number one, 4x squared minus 36. Okay, so the first thing you need to do is you need to be able to recognize that there is a greatest common factor here. And in general, that's what you need to start off any factoring problem by doing, looking to see if there's a GCF. Okay, so here I can see there's a GCF of 4, so I'm going to remove the 4 from both terms. Okay, so the GCF's removed. That is step one. Now I'm going to look into the parentheses and say, well, can I break that down anymore? And the answer is yes. This is a difference of squares. This is x squared minus 9. Okay, and we recapped difference of squares when we were talking difference of cubes. So to do the difference of squares, I'm going to do x plus 3, x minus 3. Okay, and now I'm going to again look at my parentheses. Can I break down any more? The answer is no. Once you have these terms here with the biggest power of x, or degree, being 1, that is as much as I can break these down. All right, especially because you can see there's no greatest common factor other than 1. Okay, that indicates that we're done here. Okay, so I cannot remove any more. I'm done. Just remember, it didn't matter if you did minus 3 or plus 3 first. The order of these pieces doesn't matter, but remember to keep it in proper form. We do want to keep any GCFs out in front. And as you see, always remember to bring those GCFs down. That is definitely 100% something we've improved on over the course of the year so far, and that is good to see. Okay, so if you need a second, go back, maybe rewind the tape, look at how I did that, and in a second I'm going to move on to number 2. Okay, so number 2. Okay, number 2, almost perfect. The one thing we still need to work on is fully doing out those difference of cubes. We're kind of struggling with that a little bit. So good identification, right? It's a sum of cubes. There's a sum. One of the cubes is x. The other cube is 2y, because 2 cubed is 8. Y cubed is y cubed. Okay, so now I'm going to plug in to my formula, right? Okay, so remember, x plus 2y, same. Okay, now I'm going to do x squared plus 2y Okay, and remember, see, I made that mistake too. Don't do a plus, you do a minus. Same, opposite, okay, always positive. Okay? Now, technically, I'll just be technical here and put the parentheses around those two. That's what it looks like. So it's a plus b, okay? And because this is a positive, this is a negative. So a squared minus ab plus b squared. So I'll just cross this out to make absolutely sure we've got that, okay? All right. Now, here's where we go from here. Let's clean that up. X plus 2y, okay? X squared minus, the order you put the variables, I was lenient with that. I do like to go in what we call lexicographic or alphabetical order. So I do like to put my x's before my y's. Now, here's where we kind of got a little bit tricky here. Okay, we got to square the 2, and we have to square the y, okay? This was the biggest place where we got a little bit lost. Remember, you got to square both things. So I saw a lot of 2y squareds, right? And you know why they did that. You squared the y, but you didn't square the 2, okay? So you got to square both things there. So remember, when we have sum of cubes, same, opposite, always positive. And when I say same, I mean same as this sign, right? This is a plus, same, opposite, always positive, okay? And that's why I talked about SOAP. Okay, I'm not going to necessarily require memorization of that, but in case we do need to memorize that, same, opposite, always positive. So the first is the same sign, opposite sign, and that one's always positive. Because other than that, the formula for difference of cubes is basically the same. This is an a, this is a b, an a squared, an ab, a b squared. That component of it is the same, okay? So this is just, again, difference of cubes. I can't GCF, and here's why. These don't have anything in common but one. No coefficient in common, no letter in common. Okay, so if you need a second, go ahead, wind it back, take another look, and after a couple more seconds, I'm going to move on. Okay, so I'm going to come down to the next one, and remember, as I said, the first thing we are always doing is looking for a GCF. So let's come on in here. Okay, so let's look at the numbers. 1, 5, -4, -20. No GCFs. So I'm good, not touching it in terms of the overall GCF. X's, okay, no X's in common. So again, first look, GCF, no more GCFs. I'm going to go ahead and move on. Now here, I've got an x cubed, an x squared, an x, and a 20. Now we don't have, this is not obviously a difference of cubes or a sum of cubes, so those aren't going to work. There's not a difference of squares. It's not simply a quadratic. So that what we want to do is we want to factor by grouping, okay? Now factor by grouping was definitely difficult, and we spent some time on it. So we're at a point where we either got to know it, okay, we got to come in and get that extra help and kind of boost those skills up, or you know, we got to move on. You know, I don't have, you know, we don't have more time to keep talking about this, okay? So here's what I'm going to do. I'm going to make my groups, and let's see if the groups work out the first time. So here's my groups, okay? In my first group, GCF, individually, pull out the x squared, okay? And then if I do that, I get an x plus 5, okay? That's that. Here, GCF is -4. So I think where we get kind of stuck is with this sign right here, okay? So see how I grouped it? We're just looking for the GCF of here, and because the GCF is -4, what I'm pulling out here is a -4, okay? If it was a +4, I'd pull out a +4, and then it would become a plus there, okay? So that's where we're still struggling, and that's all right. That's why we get some practice there, okay? So I pull out the -4. This becomes an x, because -4 times x is -4x. This becomes a +5, because -4 times +5 gives me -20. Okay, good sign. We can see that the x plus 5s are the same. Good. And now I go ahead, and you could do this in whatever order you want. Maybe I'll put my x plus 5 first. Again, you have freedom there because the order of multiplication doesn't matter. And here I go. Now I got to ask myself, am I done, right? It's just like this right here. Was I done here? No, but I had to examine. Now I'm going to come down here. X plus 5. Okay, biggest power of x is 1. It's done. Can't be broken down. Here, can I factor the x squared minus 4 anymore? Yes, I can, because this, like this, it's a difference of squares. Okay, so you got to break that down if you want the full credit, because it's not factored completely. Okay, so that breaks down as x minus 2 and x plus 2. Now I go back again. That's done. That's done. That's done. I can't break down anymore. Okay, so that's why you need to take a methodical approach. Start with looking for GCFs. See what you got in your tool belt, but really, you really got to start with the GCFs, because I got a lot of, I don't know how to proceed. What do I do here? There's a this, there's a that. Start with the GCF. Okay, if you can find one good, in this case we couldn't, so then we move on to our next skill. But remember, when I give you these kinds of problems, right, I'm not giving you problems that you don't have the tools to solve. Okay, you have them there, but sometimes it's a matter of, figuring out which ones you need. Okay, and that's why we keep practicing, we keep building up our skills. Okay, so go ahead, take a second if you need to, wind back, take a look through it. Otherwise, I'll move on. And just remember, the order of these three does not matter. You could have put these three factors however you want, and it will not impact your answer or credit, because the order of multiplication does not matter. All right, so now I'm going to move on to number 4 here. Now, number 4, this was a very difficult one, but again, what's the thing I said to look for first? It's the GCF. Okay, so let's look. Do they have a number in common? Yes, 2 goes into negative 2, 2 goes into 54. Let's take out a 2. Do they have an x in common? Yes, x to the 4th and an x. They have at least one x in common. So let's go and take those out. So 54 divided by 2, that's 27. X to the 4th divided by x, that's x to the 3rd. 2x, well, that's just a negative 1. So that's that right there. Now I go back again. I take a look. Okay, can I factor 2x anymore? No, that's done. How about the inside? Now I saw a lot of leaving it just like this. However, let's take a look. Well, what cubed is 27? 3. What cubed is x cubed? X. Now, sometimes we don't realize this, but what's 1 times 1 times 1? That is 1. So this is, again, a difference, not a sum. Okay, this is a sum. Difference of cubes. Okay, so here we go. We need to fully set it up. Some people got this. If you did, wonderful. If not, right, that's why we need to really be looking for this stuff, okay? So first we do the same. Remember, A, same. Okay, now we need to know 3. So I'll show you this broken down a little bit. So same, that's the same. Opposite. Okay, always positive. Okay, so same as this sign, opposite to this sign, always positive. Okay, now I do have a poster that I put up for your reference. Take a look, because I put some different colored arrows on that, and that's kind of trying to give you those visual cues to go with. Okay, so let's simplify this a little bit more. So here's our 3x minus 1. Now we got to do 3x squared. So 3 squared is 9. X squared is x squared. 3x times 1, well, that's just 3x, right? Because anything times itself is 1. And 1 times 1, that is 1. Okay? And now generally in this case, we say, can we break it down more? Now remember, with the difference of cubes, in this case, we cannot break it down more, okay? Because if we could have broken it down more, then obviously we could have factored it out, right? If this case, this is going to be as simple as we can get it. Okay, this, no matter what we do, this is not going to work out. So in this case, the difference of cubes, once you do a difference of cubes or a sum of cubes, what you need to know is you're good. You're not looking to break it down anymore. This was the looking to break it down more. Okay, so that's one typical thing we got to get kind of used to is once you get there, we're okay. We don't have to break it down anymore. We've done our difference of cubes. We're good. Okay, so again, if you need a second to kind of rewind, kind of digest, go ahead and do that. Otherwise, I'm going to move on. Okay, here we go. Now I'm down to number 5. Okay, so remember, again, following my pattern. What might be the first thing that I do? The first thing I'm going to think about is there a what? Is there a GCF? Okay, in this case, I can see one, right? Let's look at the numbers. 4, 8, 36, 72. Okay, so in this case, 4 goes into 4x cubed, or rather 4 goes into 4, 4 goes into 8, 4 goes into 36, and 4 goes into 72. Okay, you could have also taken a 2 out. You might be able to see the ones digit of each number is 2, but in this case, the GCF is 4. So let's start by taking out what we always start with, the greatest common factor. Okay, so that becomes x cubed. This becomes a 2x squared. This becomes a 9x. Okay, and this one's not easy, right? So 4, how many times does 4 go into 7? 1. Okay, remainder 3. How many times does 4 go into 32? 8 for 18. Okay, we got to start with this. Now, if you started with trying to maybe do some grouping, that's okay. That's not wrong. However, there's going to be an eventual GCF that is going to percolate out that you do have to work with, okay? So now I'm going to come in here, and if you think about it, right, it's always so much nicer when that leading coefficient, in other words, the coefficient in front of the biggest power of x is 1. You always want to have that coefficient be 1 if you can, and that's what we did here. Okay, so now I'm going to do a little bit of factoring by grouping, and I apologize if, you know what I'm going to do? I'm going to use hard brackets, and that's going to, I just don't want us to get confused here with our parentheses, okay? So here I go, hard bracket those out. And let's look at these groups. Okay, so GCF of the first piece. And remember, you always bring down that GCF, that overall GCF. Okay, so GCF of the first piece. Let's take a look. No numbers, but there is an x squared. Okay. And let's see what we get. Well, if I take that out, that would give me an x, a minus, and a 2. Okay, and you can verify that, and now I'm going to put the parentheses back, okay, just so we don't get too confused. Okay, so x, this is x cubed, that's minus 2x. Now here, and I'm sorry, it's kind of hard to see, this was actually a positive 9, so I'm going to knock out a positive 9 here. So plus 9, okay, because there's a 9 in both of these, and this becomes an x, a minus, and a 2, okay? Now notice, that's how we know, remember, and if you don't remember this, go back to the other video I made about grouping. We got it good because we see that term coming up in both of them. So now what I do is I go ahead and I do this. I do parentheses again. Actually, I don't need the second parenthesis anymore. I'm going to rewrite that. In this case, I just do my x squared plus 9 and my x minus 2, okay? And the parentheses are sometimes where it can get confusing, and I totally understand that. And if you don't believe this, go ahead and FOIL this or box this out. So that would be my x cubed, my negative 2x squared, my 9x, okay? That'll all percolate itself out, and when I distribute it, I get back to where I started, okay? Now what do? Remember what I do? I survey for more opportunities to break down. So the 4 is the 4. That's good. It's a number. I can't touch that. X minus 2. Biggest power 1. Cannot touch it. X squared plus 9. This really threw people off. Can we break that down? And remember, there is no sum of squares. And I talked about this right beforehand. The biggest mistake people try to do is they try to do an x plus 3, and I saw that come up. But let's just look off to the side what would happen. We actually get an x squared plus 6x plus 9, and we can see that these are not the same thing. So you can't break it down like that, okay? what we're going to learn is there's no way to break this down over the real numbers. And I know that because x squared plus 9, that's never going to be equal to 0 for any real number. There's no x to make that 0 for any real number. So actually, though we wouldn't think it, I'm done here. Okay, so we got to think about our tool belt. What's in our tool belt? Taking out the GCF, maybe a difference of squares, some adding to C and multiplying to B, multiplying to C and adding to B. We don't have that here. There's no B. A difference of cubes, a sum of cubes. None of our strategies, there's no tools here. So in this case, we would be done. Okay, so go ahead. If you need some time to wind it back, step through that again. Take that time. Otherwise, I'm going to move on to our next question. Okay, so now I've got 7x cubed plus 63. So hopefully you've seen the theme by now. What am I going to start with? I'm going to start by taking out the GCF, okay? So here I go. The GCF here is 7. 7 times 7 is 1. 7 times 9 is 63. This one actually went pretty well. I don't know whether intentionally or not. This one actually went pretty well, okay? So in this case, some people actually overthought it, and this was what I was really looking to see if you would do. What would you do when you got to this point? Okay, this is obviously a cubed. But what about B? Is there any number times itself that gives you 9? There is not. 9 is not a cubed. So the sum of cubes does not work because this is a cube, but remember, both things have to be cubes, right? Sum of cubes means a cube plus a cube. We have a cube, but not plus another cube. So actually, believe it or not, you cannot go further than this step right here. Okay, and that goes back to the idea of, again, you're using all the tools you can. Sometimes that's just how it happens to break down. Okay, so go ahead, take a second. If you need to go back to that analysis, do that. And then I'm going to move on to my final question. All right, so this was a tricky one. And whether or not you were there in an adjacent day, we've talked about the connection between zeros and factors, right? We know this from quadratics. This was talked about in quadratics all the way back to that point. If I have this polynomial per se, the roots, zeros, roots, or x-intercepts essentially are any values of x, which when I plug it in, give me 0. Well, I can see here, if I plug in 2, 2 minus 2 is 0, right? So no matter what I get for these two parts, when I plug in 2, I end up with 0 because I'm multiplying by 0. Okay. Similarly, if I come up and I look at this one right here, okay, when I plug in -5, that becomes 0. When I plug in +2, this becomes 0. When I plug in -2, this becomes 0, right? So this would be a polynomial whose x-intercepts, zero's roots, would be -5, because that would make this 0, so you get 0 times some things. 2, because this would make this 0, and that would be 0 times things. Or -2, because -2 would make this last one 0, and you have 0 times these two things. Now, once one of them hits 0, it doesn't matter what the value of the other ones are, right? If this is 0, who cares about the last two, right? Because once you have 0 times something, you know you're going to get 0, right? That's one of those maybe taken for granted rules that we know about numbers like the real numbers. So if I come down here, what am I trying to do? So here's what I know. -3 makes it 0. 2 makes it 0. 4 makes it 0. Okay, so let's start with my 3 sets of parentheses, and I'll drop in my x's. X, 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 okay? So what expression, which if I plugged in -3, would be 0, right? So I'm looking for x plus or minus something, and when I plug in -3, I get 0, okay? And that would be x plus 3, right? Because -3 plus 3 is 0. What about this? What expression, which when I plug in x, 2 for x rather, gives me 0. Again, what expression, when I plug in 2 for x, would give me 0? That would be x minus 2, right? Because 2 minus 2 is 0. Okay, and lastly, I'd have x minus 4. The leading coefficient here doesn't matter, right? Because let's say this was a 7. If I plug in -3, this becomes 0, and it all zeroes out. So you could have put a leading coefficient. No one did that, but just to say it doesn't necessarily matter. Now, a lot of people stopped it here, and that was good, right? In a sense, you've got the idea. This makes it 0. -3 makes this 0, so it makes everything 0. 2 makes this 0, so everything's 0. 4 makes this 0. So that's a good idea, but remember, standard form. Okay, standard form means it's got to be laid out. Now, these are all standard form, right? Notice, laid out, biggest power of x to smallest power of x, okay, in order. That's what this has to look like. So this was assessing your skills with polynomial multiplication, okay? And just like with any multiplication, the order doesn't matter. So I'll show you the first step. So we'll do this one out first. We get x squared, okay? We get minus 2x plus 3x minus 6, okay? So we simplify. We get x squared plus x minus 6. And now we have to do one more multiplication here. And for the last multiplication, and sorry for that little tilt, I'm going to do the box, okay? So remember, x squared plus x minus 6. So I'll do my x plus 4. X squared plus x minus 6. Now, before I move on, one of the really cool answers I got was 0x cubed plus 0x plus 0. That actually wasn't bad. Okay, it's not necessarily wrong because the zeros are those zeros. So that was a very ingenious, very intuitive answer. But think about it. If the coefficients are all 0, then everything makes it 0, right? That's just 0. Okay, and technically, standard form means your leading coefficient, it's defined such that your leading coefficient is not supposed to be 0. So let's do this out. This gives me an x cubed. This gives me an x squared. This gives me a negative 6x. And by the way, this is just using the distributive property, right? If I do it here, x cubed, x squared, negative 6x. So it is distributing. It's just a little bit more, in my opinion, a little bit more organized. So we get 4x squared, 4x minus 24. And let's combine those like terms. X cubed, 5x squared. Let's see, this would be what? 2x is 24, okay? So here's the idea, right? First, build this out, okay? Second, do out your multiplication here. So x squared minus 2x plus 3x minus 6. Okay, doing that out. Doing the last multiplication here. Okay, again, check the box. Boom, boom, boom. Okay, do that all out. Combine the box. This is what I got. Okay, you may have gotten something different along those same lines. Okay, I was pretty lenient with how I evaluated this one. Again, this is good start. We're gonna see it's gonna pay major dividends in the future. But remember to kind of do things out step by step. That is extremely, extremely helpful. All right, so I hope you found this video informative. I know I kind of maybe dragged things out. I know it's potentially on the longer end. If you got to this point and you really took the time to work through it, I appreciate that. All right, I spend time making these to help you better understand how these things break down. Okay, and I've actually probably spent more time with it than a lot of people got to really work through it. But that's because I really look to really break things down for your understanding, okay? So keep at it, all right? If you're struggling, make sure you seek me out for that extra help, whether through any of those methods that we've discussed, all right? And just remember, we got to have that positive mindset, right? Because we can do it, right? Remember, you can do it, okay? You can do it. I believe in you, but remember, you got to also believe in yourself, all right? Thanks again. Hope you enjoyed it. Keep working hard. And have a wonderful day.